Okay, this video is going to take you through chapter 10, section 1, the three-dimensional coordinate system. So we kind of introduced this idea of a 3D coordinate system, which is the abstract part of this and a little bit hard, and then we get into some formulas which are much easier to use. So the first thing is we're going to identify a point in space, and to do that you have to introduce a third dimension into the model. So we're going to have an XY coordinate grid, and then we're going to add a Z, which adds a vertical dimension. When we do that, it turns the X forward, which you're going to see in this situation. So if you're actually looking at a 3D grid, your X is going to come forward and back, your Y is going to run right and left, and your Z is going to run up and down. And the planes are made by the two intersections. So that horizontal plane is your XY plane, the vertical plane, the blue one, is your YZ, and then forward and back would be your XY plane. In a three-dimensional space, it looks almost like a Rubik's Cube, a four quadrant Rubik's Cube. So it's called, these areas are called octants. There are 8 of them. So if you think about an octopus, 8 legs, this is an octant, okay? And again, it's three-dimensional. So like if you are looking at your XY, this time your XY is turned side to side because this can get rotated. X is here, Y is forward and back, and Z is up and down. And it's just divided into quadrants, but instead of it being two-dimensional quadrants, it's this three-dimensional octant is what they're called. So when you go to graph, you'll notice that if it's an X coordinate, it moves forward and back. A Y coordinate moves left to right, and your Z coordinate moves up and down. All right, so you can kind of see a three-dimensional grid on this. The X runs forward and back, the Y runs right to left, and the Z up and down. So the forward is the positive X, the right is your positive Y, the top is your positive Z. So if I am to plot a point, let's say I put in the coordinates, if I'm moving my X to positive, it's going to move it forward on that X-axis. So that's your forward. If I want it to go negative, it would go backwards on that X-axis. But let's say I'm at a positive 5. Now, if I'm going to change my Y, if I go right, it's moving it to the right. If I go left, it's moving it to the left, but it's staying on that plane. So let's say we're at negative 3. Now, the Z is the hardest to see because depending on how you tip this, you have to think that typically it would be flat. And so if I wanted to move exact spots, I would have to turn this grid flat. So if I went up 3 units, it would look like that. But as soon as I tip this forward, it no longer looks like it's 3 units. And the further I tip it, the closer it gets. So you kind of have to follow, when you're graphing yourself, you have to follow the lines. And when you're reading it from a graph, you kind of have to look at the little dash lines that they give you and estimate how far it is. If you turn on that line, you can kind of see the X came forward and then went left and then up. But in order to know exactly how far, you'd have to be able to turn your grid, which you can't do on your PDF. So we're going to approximate it. All right, so the first type of question is going to be to identify which of these dots is formed by this coordinate point. So my 2, negative 3, 3 means that my X is 2. That's a positive 2. So we're going to move forward because my positive X is here. We're going to move forward 2 spaces. My Y is negative 3. So my positive Y is over here. We're going to go left 1, 2, 3. And my Z is positive 3. So we're going to go up 1, 2, 3. And this coordinate point right here would be 2, negative 3, 3. Example 2 says plot each point. So the first one, negative 2, 3, 4, means, again, here's my positive X. So this time I'm starting in the middle and I'm going back 1. My positive Y is over here. So I want to go to the right 3. But I can't just move it directly where 3 is and plot a point. I have to move it parallel to those parts. So that's about where 3 is. And then positive 4, and Z is the hardest again because this is tilted forward. So as long as I continue on in this same way, I'm going to scoop it up 1, 2, 3, 4, and I'm going to make that C. So those little like scoop marks is how you'll show me how many units you intended to move. All right, D is next. We're going to come forward 1. We're going to go to the right 1, 2, 3. We're going to go up 2. and E is last. We're going to come forward 2. We're going to go left 1. We're going to go up 4, 2, 3, 4. Now, they don't have to be exact. You're making an approximation of these, but you do want to at least show, either in dashed lines or in those little like scoop shapes, how many coordinate points you intended to move. All right, so now 2 formulas that we already know, but we're going to alter to include a third coordinate point. The distance formula, which typically is just the x and the y, we are now going to add the z to. So it's the square root of x squared minus y squared, or no, sorry, the square root of x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. And the midpoint formula that we are used to just the x and y's, we're now going to extend to include the z's. You add the 2 x's, divide by 2, add the 2 y's, divide by 2, add the 2 z's, divide by 2. So this will be in a coordinate point form, the x of the midpoint, the y of the midpoint, and the z of the midpoint. All right, so example 3 says find the distance and the midpoint of the segment between 0, 1, 3 and 1, 4, negative 2. So the first thing we're going to do is the distance. So square root of x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. And it doesn't matter which one you make the 1s or which ones you make the 2s, as long as you're consistent. So I'm going to do the square root of 1 minus 0 squared plus 4 minus 1 squared plus negative 2 minus 3 squared. I get the square root of 1 squared plus 3 squared plus negative 5 squared. Square root of 1 plus 9 plus 25, which is 35. And then as usual with the square root, you want to make sure you can see if you can break that down. That only breaks down into 7 and 5, which neither repeat. So we're going to leave it just as it is. And then we're going to do the midpoint. So the midpoint, we add the 2 x's, 0 plus 1 over 2. We add the 2 y's, 1 plus 4 over 2. We add the 2 z's, 3 plus a negative 2 over 2. I get 1/2, 5 halves, and 1/2. And we're going to leave it just like that. You can convert that 5 halves if you wanted to, but you don't need to. So you might as well just leave it as is. All right, so now we're going to talk about a sphere, which is your 3-dimensional circle. So a sphere with a center H, K, J. So if you think about your centers, H and K, that's what we've known them as. Now we're adding in that third variable, which is J. And the radius R is defined as the set of all points X, Y, Z, such that the distance between those points and the center is R, shown in the figure below. So you've got your sphere, and no matter which way we go from that center to any point on that sphere would be a radii. It could come forward, backward, right, left, diagonal, whatever it is. It's always the same length. We'll use the distance formula, which is here, to get to the equation of a sphere, which is here. So the standard equation of the sphere, we basically just take the distance formula and square both sides. X minus h squared plus y minus k squared should look familiar. That's like your circle. Now we add z minus j squared, and that equals your r squared. So in example 4, it says find the standard equation of the sphere with center 2, negative 4, negative 5, and radius 3. Again, it's x minus the h, which is 2 squared, plus y minus that negative 4 becomes plus 4 squared, plus z minus the negative 5 becomes plus 5 squared equals 3 squared, which is 9. So there's your standard form of your sphere. Last question says find the center and the radius of the sphere given by x squared plus y squared plus z squared plus 4x minus 2y plus 8z plus 10 equals 0. And you might be thinking, I thought we were done with complete the square. Well, you weren't. We get to complete the square, this time 3 times. The good news is there's typically not something on the front of your squared terms, so these are not terrible. We're going to group together the x squared and the 4x. We're going to add the y squared, then minus 2y. And we're going to lastly group the z and the 8z. z squared, 8z, and we're going to bump that 10 to the other side. And then we're going to take our second term. For the x, that's a 4, divide by 2. That's 2 squared, it's 4. We're going to add 4 here and add 4 here. We're going to take the negative 2. We ignore the sign because we're going to square it. 2 divided by 2 is 1. 1 squared is 1. We're going to add the 1 here and add the 1 here. And last but not least, take the 8, divide by 2, that's 4. 4 squared is 16. Add the 16 here and keep it balanced by adding it there. Then we're going to factor all of those that we just made into perfect square trinomials. Square root, sign from middle, put it in the parentheses and square it. Square root, take the sign from the middle, put it in parentheses and square it. Square root, take the sign from the middle, put it in parentheses and square it. And then negative 10 plus 4 is negative 6, plus 1 is negative 5, plus 16 is 11. And there's your full equation, but it says find the center and the radius. So for the center, we change the signs of each term after each letter. So negative 2, 1, negative 4 is my center, and the radius is the square root of 11. One more thing before you start your homework is you're going to get a question that will give you the end points of the diameter. So if I said 1, 2, 3, and 6, 7, 8, then for my equation, I need the radius and I need the center. Well, and you have two choices. One, you have to find the center. So I would find the center by adding these two, so 7 over 2, adding these two, 9 over 2, adding these two, 11 over 2. That's my center. And then I can plug that in, so x minus 7 halves squared, y minus 9 halves squared, and z minus 11 over 2 squared. And then I can find the radius two ways. One is take one of those points and plug them in as your x, y, z, and that will equal your r squared. And I would say if they weren't fractions, that one's not a terrible route. The other option is to find the diameter using the distance formula. So use the distance formula between these. So it'd be 6 minus 1, 7 minus 2, 8 minus 3. And I'd get 5 squared, 5 squared, 5 squared, 25 plus 25 plus 25, square root 75, which is 25 times 3, so 5 root 3. And then that's the diameter. So the radius is going to be that divided by 2. And then in my equation, it's squared. So I would square, and I would get 25 times 3 over 4, or 75 over 4. So I know I picked like terrible numbers because they were fractions. They won't always be fractions. But if it gives you the end points of the diameter, those are your two choices. First, you always have to find the center. Add, divide by 2, add, divide by 2, add, divide by 2. Then from there, you can either use the center with one of the points to plug into the equation and solve for r squared. Or you can find the distance between the endpoints, cut it in half because you want the radius, and then square it. All right, that wraps the notes. Make sure you submit for today. And then you can use the remaining time to start the homework for 10-1. But remember, you will have time tomorrow in class to work on it. Have a fantastic day, guys.